Hi guys, welcome back to my YouTube channel, and on today's episode what we're going to be discussing is the much awaited trig graphs. Don't forget to hit the like and subscribe buttons, and don't forget to drop some comments on what videos you want next. A huge shout out to my sponsor, the coronavirus pandemic. Seriously, without you I would have never thought I'd have a YouTube career. Okay, I'm done with the jokes now. Let's learn about trig graphs. Okay. So the important thing to remember when you're starting with trig graphs is you need to know what the mother functions are. That's what they're known as, okay? So up until now, we learned what the trig ratios are. We went into detail about general solution, and we even seen what special angles look like for each of these different ratios. So I'm going to start with the sine graph. I've already sketched it out, but we're going to talk about what for this mother function, what the amplitude, period, domain, and range are, okay? So the mother function for a sine graph is y is equal to sine x. Now remember, this here is a function, and basically we are finding with our sine ratio what would happen, or what corresponding y value would it give us if we input different angles into this x value, right? So these are all the degrees. These are actual counting numbers, integers, right? Or not actually integers, sorry, they're real numbers, okay? They are on the y-axis, and on our x-axis we have degrees. I went ahead and sketched the sine graph for you, and it is very, very important that you understand what exactly is happening and where exactly everything is happening. Because the minute we start shifting things or changing things, you need to be able to have knowledge about what the original looked like so that you can make careful deductions about what the new or adjusted graph looks like. So let's quickly talk about the sine graph. I'm going to just look at the positive axis, and I've only drawn in from 0 degrees to 360 degrees. Now if you notice quickly, this graph continues and continues and continues, and if you are a science student and you people did waves, you would notice this is very similar to one of those wave functions, and it's just continuing up and down in a pattern. Okay, so I've restricted the domain from negative 360 degrees to 360, but I'm just focusing for now on the 0 to 360. It starts at the 0 degrees, okay, and it increases all the way up until we reach 90 degrees, and the corresponding y value of 1, we see that there's a turning point, okay? Once we reach there, it turns down, and again at 180 degrees, it gives us 0. Then from there, it continues down, and in line with our 270 degrees, it gives us negative 1, and then it turns back around and back to the x-axis, where at 360 degrees, it's again at 0. Now, it's very important to know where all the sort of x-intercepts are for this graph, okay, the zeros are, and it's also important to note that it's turning at 90 degrees and 270 degrees, right? You should also know that the exact same thing happens in the shift it up over here. It's repeating itself basically in this 360 degrees. So you can see from negative 360 degrees till 360 degrees, I basically have 720 degrees in total. And you would also notice that in the 720 degrees, this graph has completed itself twice, meaning that it only takes 360 degrees for this graph to complete itself, okay, to make one cycle, and this here is known as its period. So I'm going to go ahead and jot that down here for you guys, 360 degrees for its period. And then if you think back to our general solution, when we had those questions where, let's quickly just scribble this down here, when we had those questions where it was 2x equals something 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 plus k times 360 degrees. When we divided here by 2, divided this value, whatever it was, by 2, and divided our period by 2, you would have noticed that this here gave us a k times 180 degrees. This here is very linked to exactly what we were just talking about the period. So I'm going to go into more detail about it in a few minutes, but basically what I'm saying over here is from here till 360 degrees, it completed one cycle. So therefore, its period is 360 degrees. If I had to change its period to 720 degrees or whatever it is, that there is represented in the graph in a certain way, and I'm going to show you that in a minute, right? Let's also then just talk about the amplitude. Amplitude is basically the difference, and I've jotted it down on another page, the difference between the maximum point and the minimum point divided by 2. Okay, so you can see from the middle sort of the graph, let's think of this here as the middle line. Now remember, if I shift this up and down, the x-axis no longer becomes the middle, right? So just be aware of that. But anyway, from like the sort of middle of the graph, right, an imaginary middle, you're looking at from there till the maximum point, how many units. If I had to stand over here, I'm standing at 0, not 90 degrees, I mean 0 in terms of y, and I'm walking all the way up. I've walked up 1 unit. If I stand here again to get to the lowest point, I'm again standing at 0, not 270 degrees, I mean 0 is in a y value, right? And I'm walking down, even though I'm walking to -1, I'm still walking down only 1 unit. So in total, the difference between the maximum and the minimum is 2 units, and then you take that and you divide it by 2, and it gives you your amplitude. So in this case, 2 units divided by 2 gives us an amplitude for our mother function of 1. I'm again going to show you guys where this changes, or if it is changed, how we represent it in the graph. For a domain, we generally give you the domain, okay? Because remember I mentioned that this graph is basically continuing and continuing and continuing forever. So we basically give you a domain restricting you from a certain x value to another x value. Sometimes they start -360 degrees till 360 degrees. Other times they start at -180 till +180, whatever it is. You're just going to look at the question, and how will you know what the domain is? They'll give you something like this. They'll say x is an element of between -180 all the way to 180, for example, both included. Okay, then you'll know that this here is your domain, meaning that we only considering our sine graph for that specific amount of values, right? However, for your range, you can look at the graph and determine that. Now let's just think quickly back to a parabola. Now we haven't done functions yet and changes and shifts in functions for grade 11, but we have done it for grade 10, right? And you know that in a parabola, and I know I'm drawing back to a parabola, but I want you to understand how I'm finding the range, okay? So let's say my parabola looked something like this. If I wanted to find the range of this, let's make this value over here -2. If I wanted to find the value or the range of this, I would say y is an element of the lowest value that it can be is -2, right? So it's starting at -2, and the highest value that this particular curve, it's a parabola, can go up to, remember this thing is going all the way up and all the way up, it's not stopping anyway. So the highest point that it can go to is infinity, and remember infinity is not included, right? That's for that one. If I had to draw a Z face parabola, let's say my value over here is 2, it's going all the way down. If I wanted to write the range of this, I would say y is an element of, and you always start with the smallest value. What's the smallest value this can be? This graph is continuing forever in this direction. So the smallest value it can be is -infinity. All the way up until, what's the biggest value that it can be? The biggest value that it can be is 2. It cannot go to 3 because it's turning point and y-intercept. You guys haven't learned anything about shifting it. So basically its turning point, the y-coordinate of it is 2, and that's the maximum value it can go to. So you're going to write that down. Now, why was this important? I was just showing you how to basically find, or how we write our range from the minimum or the smallest value you can go till the biggest value you can go. So let's quickly go back to our sine graph. The lowest value that this graph can ever go to, right, the mother function is -1. So we're going to write y is an element of between -1 and -1 is included. How do I know that? Because it's actually touching, or if I had to draw a line at -1, it would actually cut there, right? And then the maximum or the highest point that it can go to is +1, right? So all the way till 1. Let's just verify on the other side of the graph and just make sure we didn't only do it for one side. Yes, the minimum over here would be -1. The maximum over here would be +1. So we're correct. And you can draw the graph out a couple of times and confirm for yourself that this is actually true. Okay, so that there was the sine graph. Let's quickly go through the cos graph and everything you should know about the cos graph. Okay, the cos graph. If you notice the cos graph and the sine graph, okay, I'm going to try and put it on top of each other. Okay, it's not really working because we can't see the one on top of the other quite clearly on the camera, but no, wait, let's try this again. There we go. It's not that clear on the camera, but you can see that basically wherever the sine value of something is meant to be 0, the cos value of it happens to be 1. I'm looking at the very faint line at the back, right? And wherever the sine value, so I'm looking at the blue one, is meant to be 1, the cos graph one is meant to be, or is 0. And it continues like this. Wherever the sine here is meant to be 0, this one is meant to be -1. I'm just vaguely touching on the point that these two graphs are co-functions. And you guys remember this from when we were actually doing all the trig reductions and things like that. We know that if I have cos of 90 degrees minus theta, for example, you know that this gets reduced to sine of theta. And this is because they are co-functions, right? Okay, let's talk about this cos graph. So the mother function is known as y is equal to cos x. Okay, so no changes, no adjustments. We know that for every x value we substitute in here, degrees, we'd get a corresponding y value, which is an element of real numbers, okay, with a restricted domain, of course. Not domain, range, sorry. Okay, so for our cos graph, it's very important to note that our very first value that it's starting at is 1. And why does this make sense? We know that if I substitute, let's do it on the calculator, or even when you use your special angles, cos of 0 gives us +1. That's where we're starting at. Okay, it's decreasing all the way till 90 degrees. At 90, it hits 0, and it decreases even further. At 180 degrees, it becomes -1 for y corresponding value, and then it starts increasing. So at 180 degrees and -1 is our turning point, and our other turning point is at 0 and 1, and then it turns around, and at 270 degrees, it cuts the x-axis again, and then it continues, and at 360 degrees and +1, it starts turning again. It's another turning point, and you would see again for exactly the same pattern happening for the other 360 degrees between -360 degrees and 0. Quite a similar pattern happening, and you would notice if you had to investigate even further on your own and you go and draw this graph out a couple of times, you'd see that it keeps repeating itself every 360 degrees. So let's start there. That indicates to us that the period of the cos graph, that means how many degrees does it take to complete one cycle of itself, is 360 degrees. Let's fill that in. Okay, again, the domain, very similar to what I mentioned with the sine graph. We have restricted in this particular question the domain for you, okay? So that's what they're going to do in pretty much every paper, because you would see that a sine, cos, or tan graph pretty much continues forever in terms of x values, right? But we don't have enough paper or time or energy to draw the entire thing out, so we restrict the domain. For the range, very similar to how we calculated the range of the sine graph, the lowest value that it can go to in terms of y, ranges for y, is -1. There it is. So y is an element of between -1 and the highest value or the maximum value it can go to is +1. And we closing that bracket. We know that it's a square bracket because both these values are included. Okay, another thing that we should talk about is amplitude. Again, amplitude, the difference between the maximum and minimum divided by 2. Maximum is 1, minimum is -1. So the distance between those two is actually 2 units. 2 units divided by 2 is 1. And it's always divided by 2, okay? And lastly, what we need to mention is all these turning points in the shape of the graph, right? So, oh no, we did mention the turning point, sorry. It's at 1, 0 and 1, 180 degrees and -1, and 360 degrees and 1. It is very important that you know what these turning points look like, that you know what the x-intercepts are like. You know how to write down a general solution for the x-intercepts. Let's quickly do that. How would you write down a general solution for it? The very first value that it's starting at is at 90 degrees. Let me jot that down over here. So cos graph where x is equal to 0. That's what we're basically looking for, right? Think of this as your reference. This is coming towards your reference angle when we solved, okay? Angle, cos, should have wrote that down. Cos x equals to 0. Where does this happen? It's where x is equal to 90 degrees. That's the first place that it happens. And then it happens every 180 degrees later. Let's confirm this here. 180 degrees later. Let's confirm it this side. Yes, 180 degrees later. Again, 180 degrees later. So how would you represent that in a general solution? You'd say plus k times 180 degrees. This is important. They ask you questions like this, and they also, remember when I gave you guys the special cases for general solution, I gave you for where sine, cos, and tan is equal to 0, -1, and 1. Where did I get those values from? It's exactly like what I just showed you here. I started with where it's happening first, and then how many degrees does it happen, how many degrees does it take to happen again. That's what I did. Okay, so we're done with the cos graph. We need to just talk about the tan graph. Okay, quickly just talking again about the amplitude and how do we see it in the graph. You guys actually discussed this last year when you were doing graphs, right? The amplitude is actually this value right in front of our sine x or cos x or tan x, and that's what determines the amplitude. So if I put a 2 in front of here, it would mean that my amplitude is 2. If I put a 7, it would mean my amplitude is 7. So the amplitude here is also 1. For this one over here, our period is slightly different for a tan graph, okay? So we start in here, let's just look at the graph, okay? This one has asymptotes. You would notice that by the dotted lines that I've shown you, okay? So how do I know it's only 180 degrees? Let's look here. It starts, here we go, that's 90 degrees. And then we continue in from like 90, 0.00000000001. Basically the value straight after the 90, okay? Alright, and it's increasing. And then once it comes to 180 degrees, from here continuing, it's pretty much doing the same thing as it did over here. So that's how I know that this period of the tan graph is only 180 degrees. Alright. Let's talk about these asymptotes. What do they mean? Let's quickly just investigate again. Or not investigate, just type it in on our calculator. And you know this from special angles as well. If I type in tan of 90 degrees, what do I get? Math error on my calculator. It's undefined. Pretty much doesn't even touch here. Let's talk about our special angles. How do we know this, or how can you also confirm it to give yourself a better idea of what's happening? 90 degrees would have been root 0 and root 4, and we know tan was y over x. If I take my y value, it's 4 root 4 over root 0. Anything with a denominator of 0 is undefined, and that's why for these values over here, 90 degrees, 270 degrees, it's undefined. The only time these asymptotes are going to change is with the new grade 11 content that you're learning, when I shift my graph either left or right, or I change my period, okay? It still means I'm going to have asymptotes. It's just that my asymptotes will no longer be at 90 and 270. They'll just shift values or change values, okay? You should also notice what's happening at 1. We know that if I had to press shift 10 on my calculator, shift 10 1, I would end up at 45 degrees, okay? So at 45 degrees, it gives me a value of 1. At 135 degrees, it gives you a value of -1, etc. Okay, you can just confirm that on your calculator. In terms of domain, we already discussed this. It's pretty much the same concept across all 3 of the graphs. We just don't have enough paper, so we restrict the domain. In terms of range, it's minimum till the maximum. So the minimum value that a 10 graph can go to, and I have forgotten to put arrowheads. Let's quickly just do that. It continues like that. I just didn't have enough space, and I forgot to put arrowheads. Please don't forget to do this when you write in or when they ask you to sketch a 10 graph in your paper. It should have arrowheads because it's continuing for all these values. And if it has arrowheads on it, it means that it continues or it starts at -infinity. We don't know where that is. And it's coming all the way up and it's increasing up until it reaches approaching positive infinity. It's not reaching positive infinity, it's just approaching it. So we can write y is an element of real numbers. There's no restrictions on the y values. Think of this as a piece of string. This piece of string, if I had to stretch it, it could stretch from -infinity all the way till positive infinity. Okay, let's discuss these asymptotes again. How do we write out where these asymptotes are? Again, we're going to use our general solution because as you can see, it's not only happening once. It's happening here and then 180 degrees later. Let's confirm that again. From 90 to -90, yes, it's 180 degrees. Again, from -90 to -270, yes, it's 180 degrees. So it starts, let's write this down, where x is equal to 90 degrees plus every 180 degrees. And how do we represent that in general solution or in Trig? We say k times 180 degrees. K is an element of integers. And that's all that you need to know about the 10 graph. Oops, I forgot to write down here 10 x. That's all you need to know about the 10 graph. Please make sure you know how to sketch these graphs. Also please know what the graphs look like. My suggestion to you is the minute you get your paper, you just make a simple sketch of all of these graphs, okay? Mine were all accurately drawn, neatly drawn, but when you get your paper, you just make a simple sketch, indicate where the turning points are, indicate where these important points are, and what they're doing at the important points. The reason why I'm suggesting this is because the minute you start having shifts and changes to it, it becomes slightly more difficult to think about what the original is and how it got changed, okay? Especially, for example, if I change the amplitude and I add or subtract it, that means I'm changing basically direction up and down, or in a up and downwards direction for both of them, and then it becomes tricky, okay? Let's also talk about quickly before I move on the amplitude or the effect of this amplitude. What it's doing is it's basically taking, same like how our period is stretching it left and right, okay? If I have a smaller period, right, it means that it's squashing it closer and closer, okay? Whereas if I have a bigger period, it means it's stretching our graph even further apart. Whereas with the amplitude, it's basically, this is our amplitude of 1. If I have a bigger value, it's making it big, not making it bigger, it's stretching it bigger, okay? And you'll see that for every y value that it should have been, it becomes multiplied by that. Let me make more sense of that. Sorry, I'm talking in circles already. If I have, for example, at 90 degrees with an amplitude of 1, that it's corresponding for 90 degrees is 1, if I had to put an amplitude value of 2, it means that my value is no longer at 1. It is going to turn at 90 degrees, but instead of being at 1, it's going to turn at 2 and at -2. That's what it means. It's sort of stretching our graph upwards and downwards. That's what it's doing. Okay, so I went ahead and summarized everything that I basically said here about amplitude and period and even the other two shifts, okay? But I'm going to go into more detail about that. So this amplitude, where do we find it? You find it in front. It's the value in front of your ratio x, okay? So for example, I can have y equals 2 sine x. This value over here would indicate to us that the amplitude is 2. Okay, what happens if I give you y equals -2 sine x? Okay, it still indicates to us that our amplitude is still 2. Okay, what does this negative over here indicate to us? That it gets reflected along the x-axis. Now I'm racking your brain and I'm making you think back to your transformations that you did in grade 8 and 9. Grade 8 and 9 we spoke about that if it gets reflected, let's just draw a quick Cartesian plane over here. If I have my coordinate pair x and y, right, and I reflect it along the x-axis, right, my x value remains what it is. My y value becomes negative, right? But that makes no sense because I just told you it got reflected along the x-axis, but hey, my y value still stays the same. That's because if I reflect this along the x-axis, yes, my y value changes. So we would initially write it as -y equals 2 sine x, right? But remember, we always want y to be with a coefficient of 1 because it's the subject of the formula. So you'd write it, you divide everything by -1 and you'd write y equals -2 sine x. So please be aware of stuff like that, okay? If I had to, I'm just continuing with this, if I had to reflect this particular point along the y-axis, this is important for when we're doing functions also, or if they ask you a question related to it. What would happen is my x value doesn't stay the same anymore. On this side here, it becomes -x, and this here, the y value remains the same, okay? And yeah, that's all that you need to know up until this year. Next year, when you learn inverse functions, you'll learn about when it gets reflected along the line y is equal to x. But that's next year's work, and we'll deal with that next year. All right, so this is about the amplitude value. You now know about the amplitude value. Still, let's quickly recap. How do we work out this amplitude value? Because if they ask you to find the equation of a particular graph and you don't know how to find that amplitude value, then you're in trouble. What do? You find whichever graph it is. Generally, they don't ask. There is an amplitude value for your 10, but they don't make you work it out in most cases. They do, but just they don't make it in most cases. Let's talk about the sine graph. What we can do is you take the maximum, the distance from the sort of middle, right, to the maximum and the minimum, okay? What you can also do, let's say you can't find where this middle part is, right? You're panicking in the test and you can't really see this this minimum. What you do is you take your maximum value, whatever it is, all right? And you say minus whatever your minimum value is. And you read this maximum and the minimum from your graph. Okay, whatever that answer is, you divide by 2. Okay, please don't forget that it's minus because you're finding the difference between them. Okay, all right. In terms of period, and this is this year's work, it's new stuff, and I already explained what it does. It squashes the graph in half, basically, or it squashes it closer and closer towards the x-axis, or else it's stretches the thing out further away from the x-axis. Let's just look at a graph. If I had a bigger period, I'm going to just stretch. I'm taking this value here and I no longer want it at 180. I'll pull it to 360. If I want it even bigger, I won't pull it to 360. I'll pull it to 720. And it means that in that particular 360 degrees, only that much of the graph is made. What am I talking about there? Let's say I gave you a graph y equals y equals sine half x. Oh, and that's where we'd see, if you see a value in between the sine and the x, or the cos and the x, or the tan and the x, you must know that this value here is going to affect your period. Okay, so if I do this here, what it means is in 360 degrees, I will only be able to see half of my original sine graph. That's what it means, right? If I had to give you a graph like this, sine 2x, it means in my original period of 360 degrees, I would see my graph repeated twice. If I gave you y equals sine 5x, it means in my 360 degrees, I will see my sine graph get repeated 5 times. If I gave you y equals cos quarter x, it means in my cos's period of 360 degrees, I will only see this graph or quarter of this graph get produced. That's what it means, right? How do you determine this value? If you weren't given the equation of the graph and you need to figure it out, you would look at your graph and you'd see for 360 degrees how many times is it getting repeated. Now, how do you know how many times it's getting repeated? You need knowledge of what your original graphs look like, and you need to know that what a completed graph looks like. Okay, not just what the graph is, what the completed graph looks like. Then you'll know that, oh, okay, this thing is getting stretched out, or oh, this thing is getting closer and closer. Or alternatively, if we have given you the p-value and we ask you what is the period, they sometimes ask you for a one mark question. Like for example, this one here, they'll say what is the period. You would write period equals 360 degrees divided by half, and that there gives you 720 degrees. There we go, that's your period. And you would do this for all three of the functions. Okay, that's about amplitude and period. We're going to answer questions about this in a minute. Either in this video or maybe in another video I'll make where I answer specific questions about these and show you how to answer the questions. Let's talk about shifting our graph up and down. You already learned this last year. You guys must have done an investigation where you had to sketch graphs and you had to shift the graphs up and down. So this is pretty much it. It's like taking my entire graph from where it is and just picking the thing up and moving it either up or moving it down. Think of this as like a piece of string. I'm not stretching it. I'm not changing it in any way. All I'm doing, I'm not changing the shape of it. All I'm doing is I'm picking this piece of string up, I'm lifting it higher up, or I'm shifting it lower down. That's what the d value is. How would they write it? Like this: y equals sine x plus 5. This means that I'm shifting my value up by 5. Now, what does this affect? Does it affect the amplitude? Not at all, because this here is not attached to my sine x, okay? It's separate. This here is just, I'm adding a constant. So what does it affect? It affects my maximum and my minimum for my sine and cos graph, because my maximum, we already know of a sine graph, is 1. In this particular case, my maximum becomes 1 plus this 5, which gives me 6. And our minimum, which was -1, becomes +4 because I'm adding 5 to it. Okay, a positive or adding is gonna shift it up, and a negative value or a negative constant is basically going to shift it down. If it affects my maximum and minimum, it therefore affects my range. So that's the only thing that it affects, right? And then the very important, or this here is new arc and the period is new arc. So this one's the slightly not more important, but this is the slightly more challenging one and the one that we tend to question more, okay? Where we're shifting our graph left and right, okay? And this is also going to happen to all of your other functions that you learned: the parabola, hyperbola, straight line, exponential graph. This year we're just shifting everything left and right, and it's very similar to what we're doing over here, right? The only difference is the x value gets affected here. In this one here, when it's a shift up and down, the y value gets affected. All right, so if it's going a bit opposite to what you already know, you generally know that if I have a positive value, I'm sort of moving towards the right. That's a general concept that most of us have in our brains. I need you to undo that and just remember it is if I have a negative c value, I'm shifting it towards the right, whereas if I have a positive c value, I'm shifting it towards the left. Right? How do we write this, or how do we question it, or how would you know? It would be written like this. Okay. This would mean that my sine graph, I keep going back to the sine graph. Anyway, my sine graph got shifted 30 degrees to the left. Okay. It would mean that instead of it starting here at 0 degrees, it's going to start, or it's not start, our x-intercept, instead of it being at 0, it's now going to be at negative 30 degrees. It also means that my 90 degrees, whatever was happening at 90 degrees, will now happen 30 degrees before. Okay, whatever was happening at 180 degrees will now happen at 150 degrees. Whatever was happening at 270 degrees would now happen at 240 degrees. Again, I'm not stretching this in any way. I'm not changing the shape of it in any way. Same like how I explained, if this was a piece of string and I had a plus or minus d, I'd shift it up or down. I'm just taking my graph now and shifting it left or right. That's it. Okay. I'm not too sure why you guys actually struggle with this concept. It isn't a difficult one. You just need to practice a bit of past papers, and I promise the section is pretty easy because it has so many rules to it, okay? And if you just master all of the rules for trig, you'll be perfectly fine. Okay, what does this plus and minus c value do? Right, and this can go for sine graph, cos graph, tan graph, right? What does it do? It affects the turning points of my x and my sine and cos graph, because for example here it would have happened at 90 degrees and 1. It's now going to happen at 60 degrees and 1 if it is this graph over here. And then you just see it, whatever it is, you just take whatever you, and this is why it's again very important to know what your mother function looks like so that you can notice whether a graph got shifted left or right. Okay. Another thing that you should remember is sometimes, and this is where the tricky part comes, right? Sometimes I could have a cos graph, for example. Let's sketch this. Give me a second. Let me sketch what I mean. Okay, here's the scenario that I was trying to explain, and this is what I mean by it gets a bit tricky or confusing, right? For example, if I haven't given you that this is a sine graph or cos graph, right? But remember, we always give you that f of x is blah, 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 right? Let's say I didn't give you that it's a sine graph or cos graph. I've just given you this here. It's in a textbook. It's an activity, blah, whatever. And I tell you, find the equation of this graph. Now, there's two things or two ways that you can find the equation, not two ways, two possibilities of an answer. If you look at this in terms of a sine graph, you would see that this is our sine graph that just got shifted 30 degrees to the left. Perfect. I wrote that down. Y is equal to sine x plus 30 degrees. However, if you notice this to be a cos graph, right? Can you see our cos graph would have started over here? But instead of it starting, and every time when I mean starting, I mean the 0 degrees would have corresponded with a positive 1, right? It would have started over here. Instead of it happening or starting over here, can you see it starts at 60 degrees? This point here should have been corresponding with the 0, which should be 0 and 1, but it's now 60 and 1. So I can write this as y is equal to cos x minus 60 degrees. I'm implying that this graph, instead of it being a sine graph, it is a cos graph, and it got shifted 60 degrees to the right. Remember, I told you right would mean negative, whereas left would mean positive. Okay, now why is this both correct? Again, this ties in with our cofunctions, and we know sine of 30 degrees is basically the same thing as cos of 60 degrees, and that's why that is important. Don't stress too much about it, because like I said, I just needed to make you aware of it. That's what I needed to do, okay? So that you know that either way you are correct, okay? When we give you a question in a test, like I said, we generally tell you f of x is equal to something. Now, I'm going to just give you a few tips when you have the paper. What you should do is, if I tell you that f of x is equal to cos blah blah blah, whatever they tell you, please go highlight that and then go to the graph and highlight it in the same color, so that when you answer in your questions, and not particularly just the easy questions, I mean those questions that say for which values of x does whatever, right? For those type of questions, when you have the graph highlighted, it makes it so much easier to see what is happening. Also, when you see a highlighted graph, it makes it so much easier to compare it to the mother function. So please get into the habit of highlighting your graph and highlighting the name of your graph so that they correspond. Because in most cases, we don't only give you one graph, we give you two graphs, and then we ask you for intersection points. So I'll give you on top of this another graph like that, and I'll tell you what's happening, or what is this value over here and this value over here. That's what I want to know. Now, how are you going to answer those type of questions? You need to first highlight these graphs, make it easier for yourself to see, and second thing, you need to go back to your knowledge of general solutions, because this point over here is where the two graphs intersect. And if we learned anything, we know that when two graphs are intersecting, we find general solution, because it's not only here, it's happening here, it's happening here, it's happening a couple of times over and over and over. Another thing that I need to make mention, and I know this video is really long and you're probably tired of me already, you need to just look quickly at this graph. Let me take a pencil and scribble on here. We know 90 degrees is the first quadrant. Let's fill in first quadrant over here. There we go. We know 180 degrees is second quadrant, so let's fill that in over there. 270 degrees is third quadrant, and 360 degrees gives us up until the fourth quadrant. Please notice really quickly, this here is positive in this first quadrant. So this is quadrant 1, quadrant 2, quadrant 3. Wait, let's write it as Roman numerals. Quadrant 1, 2, 3, 4, right? See in the first quadrant how it's positive, and that corresponds to our cast diagram, which says the first quadrant our sign is positive. Let's do this. It also says that in the second quadrant sign is positive. Hey, look at that, between 90 and 180 it's actually positive. What do I mean by positive? I mean it's above the x-axis. We also know that here for sine graph, in the third quadrant it's negative, fourth quadrant it's negative. Hey, look at that, here it's negative in the third quadrant, and fourth quadrant it's also negative. And you can do the exact same thing for our tan graph, it's our sine graph. Here's the first quadrant, here's the second quadrant, third quadrant, fourth quadrant. We know that for 10, let's jot it down quickly. For 10, it's positive here, it's positive in third quadrant, negative in second, negative in fourth. Let's confirm. Yes, in first quadrant, it's positive. Between 0 and 90, see, it's positive above the x-axis. Second quadrant, it's negative. Okay. Third quadrant, it's positive, and fourth quadrant, it's negative. Also, remember when I did general solution with you guys, or if you look back to the previous videos, I told you guys that for 10, when we finding general solution, we only have to consider the first quadrant and the second quadrant for positive and negative, right? Positive for first quadrant, second for negative. I also told you that you could possibly do third and fourth quadrant, but you're just going to repeat yourself. It's the same solution. Let's just see that it is the same solution. Let's say I asked you for a value over here, right? If I asked you 10x is equal to 4, for example, right? Let's say it's over here. Let's pretend it's here, even though the 1 is there, but let's pretend it's here. Can you see how it's repeating itself exactly 180 degrees later, and again 180 degrees later? And that's why I told you guys that you only have to write down in one of the two quadrants, positive in here, negative in second quadrant. I promise I am almost done. Okay, same thing for the cos graph. We're just confirming, right? We know for cos graph, positive, negative, negative. Let's see, first quadrant, yes, it's positive. Second quadrant, yes, it's negative. third quadrant between 180 and 270, yes, it's negative. And fourth quadrant, it's again positive. Right, one last thing, and this ties into everything that I'm going to say in the next video that I make for you guys. Okay, the types of questions that you should be able to answer or you should expect in your paper. Okay, you need to know how to find the equation. Okay, so sometimes we'll say we'll write it exactly like this. We'll say y is equal to a sine 30 degrees, for example. Find, or first question, determine the value of a. Or alternatively, we'll give you y is equal to a cos, I'm just making, cos bx, for example, and we'll tell you determine the value of, or find the equation of, let's name this f of x. Find the equation of f of x. That's what we do. I'm going to make a video showing you how to do all of this. Secondly, they give you the domain. We discussed this already, but they ask you to state the range. Now remember, when we're giving you these graphs, we're not necessarily giving you the mother functions. We're giving you graphs that have been shifted up and down, or else have the amplitude affected. So you need to know how this affects the domain range. Let's just jot down over here affects, so that I can take a picture and send it to you guys. Affects range. And how does it affect the range? Range now becomes y is an element of between negative a, right, and positive a. That's what our range becomes. Okay, let's continue. The next thing you need to know is the effects that the shift or the period or the amplitude or whatever has on the graph. And by that I mean in words. They'll ask you to explain how it got affected. So you'll say it got either shifted to the right by how many degrees, or shifted to the left by how many degrees, or shifted up by how many units, or it has a period of whatever, or the amplitude got changed by whatever value. That's what you, or it got reflected along the x-axis. Things like that you need to know, right? You also need to know how to calculate the points of intersection. I discussed this with you. I told you it's general solution. If you're still struggling with general solution, please rewatch those videos. And if you're still struggling with that, please come and see me during break time or something like that, so that I can help you understand general solution again. It's very important. This is where it comes up again. All right. Then they ask you to find the new graph with the changes to the original. So how do they ask this? They'll tell you what f of x is, right? Or you had to figure it out, or whatever the case is. So let's say I give you f of x is equal to cos x plus 30 degrees plus 5, right? Random values. I'll tell you h of x is obtained by shifting our graph 60 units to the right and 2 units down. Determine the graph of h of x. So you need to rewrite your graph of f of x and make it h of x with the new adjustment. So I said it was, wait, let me think. I said it was 60 degrees to the right. So that means this here is now going to become cos of 90 degrees, x plus 90 degrees. And I think I said 2 units up, or whatever it was. You'd say 5 plus 2. I might have made a mistake on what I said, but you understand the concept of what we're doing. That's what you need to know how to do. The next thing you need to know how to do is sketching a graph. So really quickly, I know I said I'm almost done. I promise I'm almost done. You need to know how to use your calculator, because it's much easier than typing in all the values all the time. You totally can. You can work out manually sine of 90 degrees, get an answer. Sine of 180 degrees, get an answer. But our calculators are smart, and we might as well make them do all the work for us. You go to table mode. You type in your graph. So let's go cos alpha. You're going to pick our x value. Is it x plus 30 degrees equals? It says start. What do I mean by start? It means the first value that they want you to sketch the graph for. How do you find that? You go to your domain. So if I said my domain is between negative 180 and 180, you're going to start at negative 180. Okay, we're going to end at 180. Sometimes your calculator will tell you that there's an error. All it would mean is that there's insufficient space on your calculator to calculate so many values at the same time. So what you would do is you just break up your domain. You make it negative 180 degrees to 0. You work that out, get your values, redo the whole thing and start again 0 to 180. Let's just take a chance and see that it works. Okay, yeah, it's working so far. We'll know now. When it comes to this point here by step, what does this mean? It means from the negative 180 degrees all the way to the 180 degrees that you wanted to calculate, how many what interval can it jump in? Okay, if you say 1, that means it's counting negative 180, negative 179, negative 176. What am I counting? Negative 178, negative 177, 176, 170, all the way till 180. That's if you make your step 1. If you make your step 2, it's going to count in 2s. If you make your step 5, it's going to count in 5s. But remember, we don't want to be counting in 2s and 5s. So what we want to be counting in most cases is 30 degrees and 45 degrees. There are some textbooks that give a guideline on what you should use. You can learn that, or else you can just play around with it and set it for yourself. That for sine and cos graph, that's what I do. For my sine and cos graph, I use 30 degrees. For my tan graph, I use 45 degrees. I just switch it up a bit sometimes if they have a change. Like for example, if here they were using 60, I make sure I take that into consideration. But like I said, my 30 degrees is definitely going to give me 60 degrees because 30 times table gives us the 60. I'm sorry if I am rambling. Okay, 30 degrees equals, and there we go, it produces an entire table for us. You do not have to plot every single point. This here is just a guideline for you. So what I do is I take all the important points that can be plotted. So negative 150 and negative 0,5, that's easily plottable onto your Cartesian plane, and you just look for all the values that is easy to plot. Sometimes you might not always get such perfect values, then you just play around with it and look for the ones that are the easiest to plot. And then it's back to like normal, like when you learned in grade 9, you draw a Cartesian plane for yourself, or sometimes we give it to you, you fill in the values and you plot the corresponding ones, and then you just join your dots for yourself, thinking back to the shape of what your mother functions look like. And lastly, like I said, I'm going to make a video about this. It's for which values of x will blah blah blah. But we're going to first talk about how to like physically do all of this stuff here, and then I'll come to this. This is more of the complex or higher order questions. They're not that difficult to tackle, but we will do that in a separate video. I am sorry for talking for 52 minutes, but I'm done now.